Hey everyone, welcome back to the channel. Today we are diving into an exciting breakthrough in the world of automatic speech recognition or ASR. It's called Dolphin. It's a large-scale ASR model developed by the Speech and Audio Technology Lab at Tsinghua University and Data Ocean AI. So this model is basically shaking things up by focusing on underrepresented languages, predominantly Eastern languages, addressing the gaps left by popular models like OpenAI's Whisper. In this video, we will explore about what makes Dolphins special, its innovative architecture, massive training data, and how it outperforms its competitors. So let's stick around for a few minutes and have a deep dive into this session. Uh, so, like, why does even Dolphin exist? So, like, automatic speech recognition has come a long way. Think about how we talk to Siri, Alexa, or use any other transcription apps. They are all powered by ASR. Like we use chat option, like speech option in Google too, right? But here's the catch. Most of the models, like Whisper from OpenAI, performs best on Western languages like English or Spanish. Eastern languages, think of like Chinese, Japanese, Hindi, or Thai, are often left behind with higher error rates on their transcription. This creates a gap in accessibility, especially for regions like East Asia and Southeast Asia and the Middle East region, where linguistic diversity and the number of dialects per region are huge. So, Dolphin steps in as a bridge to cover this gap. It's designed to deliver high performance speech recognition for over 40 languages, including a variety of dialects. Plus, its open source nature, meaning like researchers and developers can access its source code and model it according to their needs. And also, they can access the like various small, medium, and large models and built on it their projects respectively. So this is a big deal in inclusive technology, making sure that more people can interact with their devices in native languages. So to understand the importance of Dolphin, we will need to know about the limitations of Whisper. So Whisper was trained and developed by OpenAI. It was trained on a massive data set of about around 680,000 hours of content, and it excels in Western languages. It's also open source in terms of its architecture and inference code, but there's a problem. Its training pipeline and data curation methods are proprietary. The like decisions taken into the development of the model are not disclosed publicly. This makes it hard for researchers to replicate or improve upon it. More importantly, like as we mentioned earlier, it struggles with the Eastern languages due to its Western-centric design. For example, languages like Lao or Javanese, which are low resource and often see much higher rates as compared to their counterpart languages. And Dolphin tackles these issues like head on with a transparent, reproducible approach and with a focus on uh, multilingual approach. So yeah, so the solution or the approach with which Dolphin implies or uses uh, is like it is built on Whisper's architecture but optimized for various other languages. It supports various languages, including some remote ones like Cantonese, Uyghur, Kashmiri, and 22 Chinese dialects from Mandarin in mainland China to Mandarin in Taiwan. Uh, Dolphin achieves significantly lower WER or word rate errors, up to 68% lower than that of Whisper. it uses data sets like Data Ocean AI, Fluorus, Common Voice, and it's not just about performance. It is also open sourced. Like we can see the data composition. Like it has a total data set of around 2,12,000 hours, and of which 1,37,000 hours comes from Open Data Ocean AI, and other comes from the open source data sets. So the data set is also well researched and available publicly. So and as we talked about the models, like different models which are available in the variants. So base, small, medium, large. So we will talk about the architecture and further slide. Yeah, this is the GitHub link. We can access it from here. So the architecture, so Dolphin's architecture is its main powerhouse. It uses an E-branch former encoder, which is a step up from Whisper's standard transformer. The E-branch former is is great at capturing both local details like nuances of how a word is pronounced in global context, like the tone of sentence, the decoder, or uh, or on the other pronoun on the other hand, it is a standard transformer, predicting words one by one to create accurate transcriptions. Dolphin also employs a hybrid CTC attention mechanism, or like CTC or connectionist temporal classification, which helps to align audio to text quickly, while the attention mechanism ensures the words make sense together and gel together quickly, while the attention reducing errors. A 4x subsampling layer shrinks the audio data. For example, turning 1000 sound frames into 250 frames, 250 frames, thus reducing its size to almost one fourth and making the process much faster and efficient. This combination makes Dolphin both accurate and speedy, especially for complex languages and dialects. So after going through the architecture, this is the repository structure of the GitHub. We come to the question uh, how does it actually recognize or analyze these languages so accurately, as mentioned in the research paper? So it uses a unique but simple and tested two-level token system, in which we use tags basically, like for Japanese, Chinese, or Swiss, German. Like we will mention a word like US, GB, like it will be Great Britain, then Mexican, Spanish will be MS, and the language corresponding to those regions will be mentioned besides them. So this helps in differentiating the languages and the regions. Mandarin in mainland China will have a different code as compared to the Mandarin spoken in Taiwan. So this system basically boosts the Dolphin's ability to handle linguistic diversity and pinpointing it to a region, making it more accurate for regional variations and for multiple dialects, including Arabic, Indian dialects, etc. So moving ahead. So the training data, the Dolphins' performance comes from a massive data set of over 2,12,000 hours of cleaned, manually transcribed speech, the bulk of which comes from DataOcean's AI proprietary dataset, covering around 38 Eastern languages with high quality annotations. The rest includes open source datasets like Reason Speech for Japanese, VetNet Speech for Chinese, Common Voice for multilingual data. This mix ensures Dolphin is exposed to a wide variety or array of accents, dialects, and audio patterns, making it more robust to across diversity settings. So, as we say, great things come with challenges also. So, there have been serious complications throughout the training of the Dolphin. Uh, as compared to its predecessor, which predecessor or competitor rather, like they only focused on a narrow bandwidth of languages, Western languages. But if we compare it with a language, the scope of languages which Dolphin is trained on, it is just massive. So the challenges are also of that scale. So it's like there have been many out of memory issues when loading the massive data set. And the solution which was implemented though was like a technique called data sharding, in which instead of loading the entire data set on a GPU, we split it into smaller chunks. So it makes the thing easier to for the GPU to grasp and the GPU handles the data only which it requires, not the complete package. So, and we have also used like 16 NVIDIA H100 GPUs. And another challenge being was the presence of shorter clips, like 5 second or 10-second clips, which used to lead, which led to high uh, WER errors, uh, ranging to about 10%, which is significant. So the team managed to solve this error by merging these clips into 25 to 30-second clips, and this drastically cut down the errors by 8 percentage points. This also like they sorted the clips into 6 length based buckets, reducing the errors further by 5% and boosting training speed by about 120 percentage points. Uh, Techniques like Adam W optimizer and label smoothing further fine-tuned the process, making Dolphin efficient and more accurate to predict in its tasks. So now let's talk about some comparison between Dolphin and Whisper. So talking about numbers, like Dolphin's performance is stellar, and on the data ocean AI dataset, the base model of the Dolphin achieves a word error rate of 29.4 percentage points. Like out of 10, 3 words are uh, conceptually wrong, whereas in case of Whisper, it is around 80 percentage for the same data set or size. The large model of uh, Dolphin, the error drops to about 20 percentage points, while for the Whisper's large V3, it is 55 percentage points. That's a 60 percentage WER reduction across the board, WER being word error rate. So on fluids and common voice datasets, a Dolphin consistently outperforms Whisper, especially in low resource languages like Lao and Japanese, where it achieves WERs as low as 10 and 5 percentage points respectively. And for Chinese accents tested on key speech dataset, Dolphin's large model hits a character error rate of just 10%, showing its strength in handling dialects. Even the base model outperforms Whisper's large V3 model in most multilingual settings, proving a testament to Dolphin's efficiency and without sacrificing any quality. So, yeah. So model variation. So Dolphin comes in with 4 sizes, as I mentioned earlier: small, medium, large, and extra large. Small, medium, yeah. With parameters ranging from 140 million to 1.6 billion. All share the same E-transformer and transformer architecture setup, trained with a joint CTC and sequence-to-sequence loss. The larger models have deeper layers and bigger hidden sizes, balancing performance and computational needs. For example, the small model has about 370 million parameters, while the larger one has around 910, offering flexibility for different deployment scenarios, from lightweight apps to heavy-duty servers. So yeah, moving ahead. We can also see various graphs, representations of like comparison graphs of the various models of Whisper along with Dolphin based on the model parameters, number of layers, hidden sizes, and attention heads. We can compare and see. the statistics. So, moving on ahead and towards the end of this session, Dolphins open source ethos are a game-changing maneuver in this field. The base and small models, along with inference code, are available on GitHub, encouraging researchers to experiment and improve it. Unlike Whisper's closed training pipeline, Dolphin's transparency ensures reproducibility and setting a new standard for open research in ASR. And you can check it out from the link in the PPT. And uh, like train or model it, you can further train and model it according to the custom needs. So further boosting its usability. So talking about what can be next for the team plans to scale the models, expand to more low resource languages, and optimize it for real-time inferences so it can work seamlessly in live applications comparable to like virtual assistants. They are also exploring model compressions to make Dolphin run on smaller devices without significant loss of accuracy. This focus on accessibility and efficiency could make a Dolphin a cornerstone or a like check a important checkpoint in the global ASR community. Dolphin is redefining multilingual speech recognition with its focus on multitude of languages, innovative architecture, and open source nature. It's not just outperforming Whisper, it's making technology more inclusive by supporting a variety of languages. And yeah, and thanks for watching. And I hope you might have gained some uh, technical insights into the Dolphin's structure. And here's the paper to access the research paper. Thank you.